This week we're playing video games and building a game controller, like this one. It's about the size of a business card and looks a lot like something from a retro game console. This little guy uses Bluetooth, so it can connect to just about any device. It's got a built-in lipo charger and a 500 milliamp battery. The parts used in this project are of course from Adafruit, and they're listed in the description below. You can pick them up on their online shop, and you can even get yourself a discount on Wednesdays and Thursdays. You're also going to need some handy tools. The Bluefruit EZ-Key is the star of this project, and it's basically a Bluetooth breakout that's designed for making custom keyboards. I've built a few projects with the Bluefruit EZ-Key, and I think you could totally make something really cool. I have lots of arcade style ideas here, and I definitely encourage you to brainstorm something unique. To start off, I'm going to use the half-size Perma Proto breadboard. I started by laying out the buttons on the PCB to make the D-pad, and the two in the lower center will be the start and the select buttons, while the two on the right are going to be the A and the B buttons. This is of course my design, but you can lay out however you want. So once I finalized design, I proceeded to solder them in place. But this is really nice because the through holes are actually gold plated, so they won't get oxidized or peel off with rework. Next up, we need to wire up the buttons to the ground pins on the breadboard. I recommend using 30 gauge silicone coated stranded wires because they give you the bit of movability and they won't kink as much. You'll definitely want to measure the wires before cutting them up into bits, and these are going to connect to each button on the ground rail on the PCB. So try using the shortest wires possible. So I had to remove two of the bottom corners from the Perma Proto PCB because it just wouldn't fit inside the enclosure. The standoffs in the corners are kind of in the way, so I had to trim them off using a rotary power tool. And of course, I recommend doing this in a well-ventilated area, wearing safety things, and I recommend using one of those thin cut attachments. That seemed to work pretty well. Now let's wire up the power circuit. So I started by soldering two wires to a slide switch and then sealing it with heat shrink tubing. Two of these wires are going to go in between the Bluefruit EZ-Key and the charger. So the switch basically makes and breaks the positive connection, making it power on and off. Now the last connection we need to make is ground. And the 500 milliamp LiPo battery already has a JST cable on it, so that just plugs into the JST port that's on the USB LiPo charger. Okay, so once I have the power circuit tested and working, I'll wire up the buttons on the Perma Proto. I made the wires long enough to move around the components, but you don't want them too long because that could probably make it difficult to fit into the enclosure later. So the order doesn't matter too much on the EZ-Key, but it is important to wire the buttons with the input being on the opposite end of the ground connection. So make sure to double check the polarity. Once all the buttons are wired, I grouped them up and added some heat shrink tubing just to keep them together. And that's pretty much the whole circuit. It's really simple and easy to wire. I put together a full step-by-step tutorial on the Adafruit learning system, so you can check that out and follow along while you build it. Now, how about we build a nice 3D printed enclosure, like this one. So here it is. It's a really simple two-part design. The two main components are mounted to the bottom cover, while the breadboard is mounted to the two standoffs that are on the left and the right. There's just enough clearance in between the Perma Proto and the cover, so that's where the battery is going to go. The parts are fairly small, so they're going to fit on most desktop 3D printers like the PrinterBot Simple Metal. I mostly use PLA for my projects, and it's safe to slice with no support material. The parts are oriented to print face down, so it's really important to get that first layer really perfect. I also printed the cover in a different color, so it gives it that nice two-toned look. The buttons print really well in NinjaFlex. It's that TPE material, because it gives it that grippery, rubbery feel, and they're of course flexible, so it works really well here. Now that we have our parts, we can mount the micro USB LiPo charger and the Bluefruit EZ-Key to the bottom cover. We'll use number 440 flat Phillips machine screws, and once these two are secured, we'll mount the Perma Proto onto the two standoffs. Now we can insert the NinjaFlex buttons into the enclosure. You'll definitely want to keep those in place while you insert the circuit, and we'll just slide it in at an angle and slowly fit it into place. So before closing the enclosure, you'll definitely want to pull out that slide switch and fit it into the cutout. So once the slide switch is snapped into place, we can close it up and fasten those machine screws into the corners. To finish off the project, I'll add a bit of fun tack to the cover and just press it down. And that's pretty much it. Now we have a custom Bluetooth gamepad. I did a lot of testing on the couch and played my favorite arcade games on the TV. It also works really well with Android tablets, but you can pair it with just about any Bluetooth device. This one is a lot of fun. It gives you solder practice, and when you're done, you have something really cool to play with. I really hope you guys enjoyed this one, and you can let me know what you would build in the comments below. Thank you so much for watching, and be sure to check out our 3D Hangout show on every Thursday, where we show CAD tips, some slice settings, and some other cool 3D printed projects. So until then, remember to make, share, repeat. I'll see you guys next week.